Hello everyone. In this video, I'm going to explain the way just to find out a predecessor of a node in a threaded binary tree. Here, this binary tree is over there and equivalent threaded binary tree is already drawn. You can see the things here. This is the one extra node that is called header node or root node, and entire this tree will come as a left subtree of this a specific header node, and in the right side this as a right child, this node is going to point itself over there. So that is overall structure of this tree as a threaded binary tree. Here I am trying to find out once again a in order predecessor of a node. Here I have to find out the predecessor in this threaded binary tree. So before defining the predecessor of the threaded binary tree, I have to understand what exactly the fields required for this node, any one of the node. Here if you will see, there are the 5 fields that is going to point some specific things once again. And here I'm trying to write a pseudo code in a C language. Somewhere I'm taking the I'll go to just explain a node as a structure, and it is like a linked list representation over there. So I'm here assuming you people know about the structure, C structure, as well as the pointer and the little bit linked list, about linked list. So here I'm creating first the overall fields that any one node has. So their node, for this node what exactly the requirement is. So I'm explaining here from left to right what exactly the representation is over there. So that is L thread, then that is the L child, and then once again it is data. So then R child, and then R thread. Now I'm here trying to specify the things. So this one is here. If I'll take L thread, it will take value either 0 or 1. That's why I'm taking as a set, because this L thread will have the value 0 or 1 only. L child, it is as a pointer. It's pointer to point left child. But exactly we do. But here extended. So besides left child, it can also point left, or you can say also point left child, can also point predecessor of that node. But generally L child, that means it is going to point a left child data, so related to information whatever the node holds. Then R child, once again the similar to this one, pointer to point R child, right child. R thread, this is also, it will also have the value of 0 and 1, and if this value is 0, that means the this field R child will go to point somewhere the thread, and if its value is 1, that means it will go to point right child. Similarly, in the case of L thread, if value is 0, so it will go to point left thread, not left child, and if its value is 1, so in that case it will point left child. So this is the overall structure, or you can say the information related to the field. So and the last, end node. So there is end node. So this is the overall fields which is related to any one of the node. Now for this node information, I'm trying to write a structure of the C language. So what exactly the things will be there? Here I'm trying to write the structure of that thing. Struct. So we know there is the requirement to keyword that is called struct. So I'm creating here a struct node, that is the name of your structure. Then for this L thread, so here I'm taking like a, because in this information this is 0 or 1, so I'll write int L thread. Similarly I'll write for int R thread. You can also write boolean Here I'm taking 0 as a 0 and 1 as a integer. You can take boolean, so true, false, or in the way of 0 1 also it is representing. So boolean you can also write, but here I'm taking integer. For the data for this tree, as a, because information here A B C D, that is like a uh, in the form of character, so I'm taking character data, and you are free to write whatever. So in the generalized way, if you are writing data type data, you can write. Clear? The data, then what exactly the requirement, these two pointers. So what exactly the way to declare the pointer, because these pointers of the type of node type itself. So what exactly the type, struct node. So I'll write struct node, and that as a pointer. So normally after writing a struct node, that is the data type, and we can declare a pointer as we are doing for the normal pointer. So a struct node L child and a struct node R child. So that is the overall structure. So this is the structure of your node. So entire node information structure is like that. In this way we'll write. So after that semicolon. Here the data type is a struct node, but repeatedly I do not want to write a struct node. So there is the another way of renaming. That's I'm doing over here. Type def struct node, and I'm trying to give this one as a name node. So this is node and semicolon over there. Here also semicolon, and after each and every syntax there will be semicolon over there. Clear? So that is the overall structure of this one. Now using this, now I'll take this node as a data type, and for this data type, for this node data type, I'll try to create a function for this in order predecessor. So here I'm wiping out all these things from this place, and here I'm declaring the function. So what exactly the signature of the function first, that means requirement. Here I'm giving the name in order successor, so I'll write in order predecessor. So in order pred I am writing as a name. Return type, so first of all I'll take the parameter. What exactly parameter, I'll give any one of the node simply. So node will be pointed by any pointer of the type of this node. So that's why I'll take, I'm declaring here pointer node, a type here I'm taking n. Return it, because I'm looking for the predecessor, that will also of the node type. So a function name is here in order predecessor. Parameter is of the node type, so I have taken as a pointer, node type pointer to point that is specific node. And then return type is also a node type, so I'll take this thing as a return type. So node, here it is defined in a capital, so that's why I'm writing node star. It is also a pointer type, so it is there. Now I have to define the body. That means in a function I have to, that is the overall signature, means this is a return type, this is a function name, this is function name, this is the return type, this one is function name, and this one is the parameter list. So this is the overall prototype of the function. Now I am going to define. So I'll start from here. I'm looking for the predecessor. So first of all I'll put, because I have to define the function, so curly braces I'm giving. Here writing the pseudo code little bit in a function. I'm exactly writing the function in C. So I'm assuming you people have the knowledge of C, fundamental of the knowledge of C. So in that case, what exactly in order predecessor. So in case of in order predecessor, always for the in order, it will take the things of L, V, R. So that is the sequence of the in order. In order sequence is always like a L, V, R. So L, that is the vertex, whatever you are looking for, or root you can say, that is the right, and this one is the left. So for any one of the node we are looking, because that is V. So predecessor, that means left side. So I'll come for any one of the node N. I have to come for the predecessor, so I'll move in the left side. So what exactly the things will be there for moving left side, and that left side is also for any one of the node. If you will go the left side, that is also going to point some memory space of the node type. So I'm declaring here a pointer of node type, node pointer P, which will go to left side of this N node. So this will go to point left side. So N dot L child, that I'll put over there. Clear? After that I'll check whether it is a thread, because traversal will be done till your thread value is 1. So what exactly the thread value I'll check, because I'm moving in the left side. So first of all I'll check whether this L thread L thread value is 1 or not. So if N dot L thread is equal to 1, if it is there, so inside what exactly I'll do, if it is there, so because I'm looking for the predecessor, so in that case I'll come in the left, and then I'll go to the right side till I'm not getting the this value or leaf node, till I'm not getting the leaf node. But here it is not the leaf node, so if the value of this uh, r thread is equal to 0, so in that case I'll move right side. So that's why while left right, first I'll come to the left side and then I'll move to the right side till I'm not reaching to the leaf node, means where the thread value is 0. So while which one, while P, because that is the child. So P dot r thread, P dot r thread is equal to 1 till this condition. While P dot r thread is equal to 1, if it is there, if it is satisfying, so in that case P will go to point P dot r child, and after that this loop will terminate, and this if condition will also terminate. And in the last, what exactly I'll go to return, so I'll return P, and that will be the predecessor of any one of the node. So the pointer P is going to point some node, and that node will be the predecessor of the node N. Now I am explaining this code to this tree. What exactly, suppose if I'll take any one of the, like I'm taking A. So in that case, here first of all I'll try to write the first in order traversal of this tree, and then I'll try to get whether it is working over there on this code or not. So for the in order traversal of this tree, A, B, C, D, E, what exactly the in order traversal of this tree? So in order traversal, if I'll do, that is B, D, A, and then E, and then C, that will be there. And after adding this, creating this threaded binary for this binary, so header node, here I'm taking header node as H. So H will here also like a predecessor of B and a successor of H. So we have to find out whether this code is uh, correctly working on this tree, just to find out this sequence properly or not. So check the things I'm here trying to make it. So first, this sequence for A I'm trying. So we'll try to get whether find out it is giving D or not. So here I'm simply putting the value of N as a and an argument I'm giving A, the address of A here I'm giving. So in that case, what will happen? This N will go to point this location, and P as a pointer, it will go to point N L child. So N L child, this is pointing over here. So the P will point this location, and after that, after pointing this thing, I have to check whether N L thread is equal to 1. N L thread, this value is 1. So if it is there, so I'll try to traverse in the right hand side after moving left in the right hand side till I'm not reaching to the value of this r thread is equal to 0. So well, I'll check while r thread is equal to 1. So p dot r thread, just see here n dot l thread. So n dot l thread this value, and now I'll check whether p dot r thread. So p r thread this value. If it is 1, this is in the loop, this is in the one time for the condition. In the loop, so it will go, this is here, right? So what exactly I'll do? P will go to point P R child. So P R child, this is pointing over here. So P will be removed from this position. Now P will start to point this location. Once again I'll check because it is in the loop. So it will check whether P dot R thread. Now it is 0. So it is 0. That means the loop terminates here. And then if body is also terminating here, then you have to return p. So this p will going to return what exactly the value it is returning. It is returning d. So you can check the predecessor of a is here d. Clear? Now I'll try to get the predecessor of this b. So what exactly will happen? So in that case, if we'll go to just get the predecessor of b, so here just put at the place of n. So n will go to point the address of b. So here I'm removing the this thing again and trying to make the things clear whether it is giving the result or not. For the b I'm looking, so this is the b location. Here I'm passing the address of b for this function. So n will go to point this location, and after that node p, once again it will in the repeated way for the l child. So what exactly the l child, there you will check here in the l child memory address is here p, because that is h. So p will go to point once again this location. So this is p after reaching, because in the l child it is pointing to this as a thread, it is pointing to the head node. So it will go to their p, and now after that I'll check whether n l thread. So n is here, l thread value, this value, it is 1, not 1. So this body will not execute. If body will not execute after if body, because this is your while body, this is your if body, and it will not execute. So in the last, this return p. So p will going to return as a predecessor of this b. So what exactly the value is p is returning, that is h. So you can check h is the predecessor of b. Now see, if I want to see the predecessor of h, what exactly will happen? Suppose whether it is giving c or not, just check that thing. Just see this body. Here I am trying to once again put this value for this p. Here I am passing the address of this header node. So here n will be like, this is n. Clear? Now I'll give what exactly? Node p, that is going to n child. So n child, here it is a. So it will go to point this p. Clear? So a is pointing the node a. N is over there. Now I'll check whether n l thread is equal to 1. N l thread is equal to 1. If it is there, so I'll try to traverse till p r thread is equal to 1. So I'll check p r thread. R thread, this value is 1. So if it is there, so p will go to p r child. So p from here, it will come to the, here this p will come. Now p will come here. Let's see. Once again it will check whether p r thread is equal to 1. P r thread, no, it is not 1. 0. So this entire if and while body will terminate, and the things will be return p. So return p, what exactly p is returning c. So the predecessor of h is c. Here predecessor, here node n, for this p the predecessor is c. So it is satisfying the sequence. So in this way we can find out the predecessor of any one of the node in a threaded binary tree using this pseudocode. That's all for this video. Thank you for watching it. Kindly subscribe and like the channel to get latest videos and updates. Few more channels are also there in the last to get latest updates in new dimensions and domains. Kindly subscribe and like them as well.